Okay, welcome to day one of our second unit, and the second unit is about matter and classifying matter and all of the changes and properties that it goes through. So we did not actually take notes and have a lecture on this material, but I'm going to go ahead and video this pretty briefly probably. What they did in class instead was they did a classification of matter activity, and were able to get all of this information by working together and discovering it themselves. They also did have these notes in front of them, so I'm just going to highlight a few things about this. The first thing you can see is that matter is anything that takes up space and has mass, so has volume and mass. And we can see that we can break matter down into either being a pure substance, or the next part of this says if it's not a pure substance, it's a mixture. So pure substances, that means that we've got only one type of material that is in that sample. So that type of material might be an element, or it might be a compound. So elements are composed of a single type of atom, whereas you see compounds are composed of two or more of those elements, so two or more different types of atoms. Starting with elements, can't break it down any further and still have it retain those properties or characteristics. Also, we see that an atom is considered that smallest particle, and it is possible to have a molecule of an element if more than one atom of the same element is chemically bonded together. So for example, if you have something like hydrogen, that is still considered a molecule of an element. So we have a couple little examples here. Compound, remember it's going to be two or more types of elements. That's why this, hydrogen, does not fall into the category of being a compound. It's an element. And we see that compounds can only be separated by chemical means. When we refer to the smallest particle of a compound that still retains those properties, we refer to it as a molecule. And then there are different ways that you might see compounds written. There are both inorganic and organic. Don't worry too much about knowing those differences quite yet. We'll focus on that later on, but notice what you see is you actually see a formula, something with element symbols and subscripts. All right, so if it's not a pure substance, that would mean it's a mixture. So you've got two or more types of materials. Those types might be, that mixture might be homogeneous, or it might be heterogeneous. If it's homogeneous, another term for that is solution. What that means is with the naked eye, you really can't see any different pieces and parts to it. It looks identical. So we have some examples here. Maybe be familiar with these terms, even though we're not going to focus on them too much quite yet, but the solute is what's being dissolved. A solvent does the dissolving. So if you have a solution, remember a homogeneous mixture, then those are going to be the parts of your solution. Heterogeneous, what that means is that you can identify different parts with the naked eye. So it's got more than one identifiable component. So there's some sort of boundary, an interface boundary, between those two different components. And you can see some examples there as well. Okay, so then what we notice is that you can only separate compounds by chemical means. But with mixtures, they can be separated by physical means. And some ways to separate mixtures would be things like distillation, evaporation, filtration, decantation. We're asking that you guys look that stuff up a little bit. You've got Mr. Google to help you with that for your homework. But just to give you a rough idea, if we had something like, I guess we can start with chromatography here, that chromatography, it's separation by physical means based on different rates of flow, so based on different solubilities of substances. Centrifuging is when you have a density differences, and so when you spin it around really quickly, the denser particles are going to fall towards the bottom. Evaporation, I think everybody's done that at some, or seen that at some point in their life. So you have something dissolved, you have a solute dissolved in your solvent, you've got this solution, and you remove it, you change phases basically. The liquid, the water, turns into a gas and disappears, and you have that solid left over. Filtering would be when you have two different substances, a solid and a liquid, and that solid stays down in the filter paper. Distillation. What makes this different than evaporation is that distillation occurs when you have two liquids, um, two substances that both have boiling points to them, but they have different boiling points. So if you had water and alcohol, for example, the alcohol will boil off and turn into a gas before the water will, so therefore you can collect it separately. Decanting, fancy term for pouring off. So here we have some sand down at the bottom. You decant or pour off the water. Heating, what we're going to see here, these two, I just happened to grab this from some little thing. Those two are not physical means of separation. That's going to be chemical means. So we'll talk more about that another time. Okay, our matter classification chart. We see that matter, all matter, can be broken up into being a pure substance or a mixture, just like we mentioned. These guys, mixtures, can be separated physically and broken down into their pure substances, whereas your pure substances can only be chemically separated. If it's a compound, it can be broken down chemically into its elements. Of course, elements cannot be broken down any further. And then mixtures, what we're talking about is you can have a homogeneous or a heterogeneous mixture. You've got a flow chart on your notes. And then again, here's another little flow chart of that material. You can stop and stare at this if you would like. And it's got some little tidbits for you, little examples. Okay, so I think we went through these examples. I think they did this in their little activity. So if we were talking about something like alcohol, we're now trying to think about this on a big macroscopic level, I guess. Alcohol has a chemical formula to it, so therefore it is classified as a compound. Water has a chemical formula to it, H2O. It is a compound, cannot be broken down any further by physical means, only by chemical means. In other words, electrolysis would break it into hydrogen and oxygen. Ice cream, this looks like Rocky Road ice cream. There is no chemical formula. It is not a single element. You don't see it on the periodic table. Therefore, it is going to be a mixture, and I see some marshmallows and nuts. Boom, over there at the heterogeneous. I can see all the different pieces and parts. Carbon dioxide, CO2. There we go. Pure air composed of nitrogen, some oxygen, some carbon dioxide, some water vapor, all sorts of things are in our air. So it's obviously going to be a mixture. I can hold a sample right here in my hand. You can't see this, but I'm holding a sample in my hand, and I cannot pick out the pieces and parts to pure air. Therefore, it is homogeneous. What we're going to see is that all gas mixtures are homogeneous. Okay, this one says oxygen. I see it on the periodic table. There we go. It's an element. Soil. I see a worm, some rocks, some clay, all sorts of different things. So it's heterogeneous. Chlorine. It's on the periodic table of elements. Iron, periodic table of elements. And finally, sugar water. Let's pretend for a minute that that lemon and those ice cubes are not there. Just sugar water. You wouldn't be able to tell one teaspoon from another of your sugar water. So let's call it homogeneous. There. Okay, so now I want to get to thinking about matter on an atomic level. And we did do this in class. And you should be able to do this for a quiz, for a test, so make sure you understand this. What we're looking at, I am pretending that what I have here is a beaker of some substance. And I'm able to magnify it extremely to where I can see all of those individual atoms, molecules, whatever might be in there. So I'm going to classify these things. I want to categorize. I want to figure out, first of all, is this sample that I have in front of me a solid, liquid, or a gas, or a combination of different phases? So the first thing, I see that this has got to be a gas because it is filling up the container. That's what I would expect for a gas. It's not all laying on the bottom in a crystalline structure, which would be a solid, or in some sort of flowing motion down at the bottom, which would be a liquid. gas, totally random distribution of particles. Next thing, is it a pure substance or is it some type of mixture, and what type would it be if that's the case? Well, every single thing looks the same, therefore it is a pure substance. There's a single type of matter in the container. And then finally, element, compound, or is it a mixture of both elements and compounds? It is just elements, or an element, because there's just one type of atom that's shown there. So an example for this might be neon gas. That would be a good example. Okay, here we go. So in this example, I'm first trying to decide whether or not that thing, which that's all I see in there, is that going to be a solid, a liquid, or a gas? And I see that it's not filling up my container, so it's not a gas. And it's not in a nice crystalline structure, like a nice patterned arrangement. So I am going to go with liquid. Okay, next one. Mixture or a pure substance? Everything looks the same. I'm going to go with pure substance on that. And last one, is it going to be a pure substance that happens to be an element, or a pure substance that's a compound, or is it both? And the answer is compound, because I've got different elements. Those are not all the same there. Okay, next one. This is going to be, it fills the container, looks like a gas. And is it a mixture or pure substance? Ooh, what is that? That's wrong. Who put that there? This is a pure, let's write that big with black, pure substance. And then, by the way, it was me that put that there. I made this, so I'm the only one to blame. And then the last thing is element or compound, and the answer is element. Okay, next one. Again, it's filling the container, so you should be thinking to yourself, that looks like a gas. And is it a mixture or a pure substance? Ooh, I see some of these guys, and I see some of these guys. Those are different from one another, so that looks like that's got to be some sort of mixture. Remember what we said about all gas mixtures. All gas mixtures are homogeneous. So there's no way with your naked eye you would be able to differentiate between those two different types of substances. And then finally, what's in here? Well, that looks like a compound, right? Two different elements. This looks like an element because you've got two atoms of the same element. So you've got both compounds and elements. Okay, next one. Ooh, this one's a little tricky, but it's not a gas, it's not filling the container, and it's not as nice and crystalline and structured as I would like, therefore I'm going to call it a liquid. Looks to me like with the naked eye, I would be able to differentiate this boundary. So, first of all, this guy right here is not the same as this guy. So I know it's not a pure substance. I've got two different things in there. So it's got to be a mixture. And because I could differentiate that with my naked eye, and I know that this doesn't really fall into this category with because we're just looking at atoms. But if I think about like oil and vinegar, that's the type of thing I'm expecting to see with that. So I'm going to call it a heterogeneous mixture of elements. All right. That looks like it's all down at the bottom. That doesn't happen very often with gases. I know this is a little tough one to differentiate between a solid and a liquid, you know, drawings for this. So, but let's just call it a solid because it's as, you know, patterned as it could be. Next one, mixture or pure substance. Looks pretty pure to me. And then of elements. Those are just all the same guy, just one of them. All right, I like this one. Again, we see it's not a gas. I'm not even going to call that a liquid. I'm going to call that a solid because everything is very patterned. You've got alternating atoms of this. Well, am I going to call that a mixture or a pure substance? Notice that those atoms are not touching one another. So it is not going to be anything about compounds. Instead, I've got this atom, which is different than this atom, but not bonded, just hanging out as a mixture. Now here's the key to this. your naked eye would never be able to differentiate between two different atoms sitting right next to each other. And they're nice and patterned. What this would be an example of is an alloy, something like brass or bronze, something like that, a metal that is really a mixture of some different elements, different types of metals, but to your naked eye you couldn't be able to differentiate that. So that's going to be a homogeneous mixture, and it's a mixture of elements. Is that it? That is it. Nicely done. That's day 1 of Unit 2.